Okay, so we've been looking at bivariate data, and what we've done so far is when we've looked at the two variables and we've created a scatter plot, and we've made sure that we've put the explanatory variable on the x-axis and the response, and then we've looked at the scatter plots, and we've looked at the R values, the strength, and we've also looked at the R squared value, which tells us about the relationship between and, you know, how much variation and things like that. So now what we're going to do is we're going to be fitting, it's like a line of best fit, but we're going to, so this line, we're going to find that line and the equation of that line. So that line is called the least squares regression line. So might write that. So write that least squares regression line. So that's what they're going to refer to it. And it's sort of like the line of best fit. It's just found in a mathematical way where they're looking at all the dots and they're balancing it out and things like that, okay? We don't really have to get our calculator. We'll calculate it for us. So we're going to get this equation of this line. And because it's a straight line, it will have a basic formula like this, that y equals a plus bx. But obviously in our scenarios now, we're not going to have y. We're not going to talk about y. We'll talk about it being the response variable. So we'll have whatever that is. So in our examples in the past, it has been, remember we were looking at, a lot of times we looked at weight. So for an example, we would have weight equals. Now, this A value will be a number that we calculate on our calculator. So this A value we'll get off our calculator. Then we'll have, so we'd have A, then we'll have plus, and this B value is known as the gradient, and it's another value that we'll find off our calculator. And then we'll say times by the explanatory variable. So in our example, we would have called that, we were calling that height. So instead of writing actual y and x, we'll now write the variable names. Okay? Sorry, and they should have had b times height. Okay, so we have to remember a few things. So where our line crosses that y-intercept, that's the A value. So whatever that is, that's the A value. And we know that the B value is the slope, or you might want to underline the gradient. So we used to call it M, and we used to call A C, but now we're always going to call them A and B. Now you would have noticed when you're in your calculator, and we were finding, so when you're in your calculator and you're on lists and spreadsheets, and you've got all your lists, so would have our explanatory variable listed down there and our response variable blah 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 down there, where we went and found, remember, our R value and our R squared value. So remember we pressed menu, statistics, stat calculations, remember all of that, and we end up going to the linreg function, the A plus bx. You'll also see A is listed and B is listed. So we're going to just go find those values off there, and then we can write out the equation of the line for our scenarios. So let's go. It's really important though, you have to make sure you've put the right variable in as x. So you've really got to make sure you decide the right EV and the right RV, because it would get a different answer. So moving on. So the calculator is one way to find the A and B values, but there are some other formulas, and here it is. So here's an alternative to find B. Now you can see it's got those letters in there, R and SY. So down here I've told you what that is. We should know the R is the correlation coefficient, so we know that, that's what they call it. And when you see SX or SY, it just means standard deviation of X and standard deviation of Y. And then if they have X with the line above it, it means their mean of X list and the mean of Y. So when you get this scenario, what's happening is they often give you all those pieces of information and you have to calculate. So let's do this example down here together. And you can see it says the heights and weights of 11 people have been recorded, and they're going to give you the following stats. So you can see here, sorry, this should have a line above it, the X. They've given us the mean of X and they've given us the mean of Y, and they said use the formulas to determine the least squares regression line. So when you go, if we were going to go do the answer, so we know least squares, I'm just going to abbreviate this, regression line, that's when we need Y equals A plus BX. So if you don't have the list to enter, which I don't in this scenario, that means we're most likely using these formulas, which we're going to, because we haven't been given the list. So I have to calculate this B value, and I also have to calculate this A value before I can write it out. So I'm going to write the B value first, or calculate it. So the formula says to do R times the standard deviation of Y times X. All right. So we can go down here and we just get the values out of the example. So they said R was 0.8502. Then I'm going to times it by SY, which I can see is 7.5943. And then I'm going to divide it by the standard deviation of X, which is also written there, 7.443. So we'll pop that in on our calculator and we'll get this on the calculator ends up being 0.86. I'll just do 3 decimal places. So 867. And now I'm going to go find the A value. Now the A value, can you see you actually have to use what you calculated for B. So you can see you've actually got to use that B value. So when you're doing this, you must calculate the B first if you've got to do the whole thing. So let's go and work this one out using what we're told. And they told me the mean of Y was 65.4545. Then I'm going to do minus the B value, which was 0.867, and then times by the mean of X, which they gave me, which was 173.2727. All right, so we do that on the calculator, and we'll get a value. Okay, so I get that to be negative 84.77. I'm just going to do 3 decimal places. So now I've got those 2 values, I can write out the equation. So you've got to be careful. So I'll now write out full equation. And this is what you've got to make sure you do this. So therefore, now I'm not going to use X and Y now. I'm going to use the variable names. And they told me that height was X and weight was Y. So I can write it out. So I'm going to write weight equals, and I have to write the A value. So negative 84.773. And then I do the plus the B value, which is 0.867, times the explanatory variable, which was height. Okay, so there's my final answer. That's what they're looking for. And then what we're going to do is once we have these equations, and we'll do that in our next lesson, is we'll use it to predict, you know, what we can predict maybe. Using this data, we can make a prediction of what someone might weigh if they had a certain height. Okay, so what we're going to do now is if we do have the lists and we need to do the equation, so everyone's going to do this with me on their calculator. So looking at this, these are the 2 lists. So you're going to, we're going to do it on the calculator, and you're going to enter these 2 lists. I'm going to yell. All right, so we put these 2 lists in our listen spreadsheet. So we had income and we wrote them in, then we had carbon dioxide and we wrote them in, then we went and did our stat calculations and so on. So we've ended up with A being 1.38 I'm just going to do 3 decimal places, and B equaling 0.41, I'm going to say 7. Okay, so now if you had to write the equation, what we would write is CO2, and we'll put the units in brackets. So CO2 in tonnes equals the A value, 1.389, plus the B value, 0.417, times the income, and we better put, it was in thousands, so just put whatever they had in brackets in there. And that would be writing the equation, okay? So that is the least squares regression line. So they call it the least squares regression line. So that's the equation of that line. I'll call it equation.
Was that last thing in brackets?
0 zeros. So this is because it was measured in thousands. Okay.